Hello and welcome everyone to my presentation. To understand this topic, it's actually very important that we first of all get a sense of what soft matter is. So let's go to that. Yeah. So materials which have properties in between that of crystalline solids and liquids, they're generally called as soft materials. Now, while crystalline solids are elastic in nature, liquids are viscous in nature, soft materials are usually viscoelastic in nature. Now they have mesoscopic structures and the energy associated with these structures is around approximately kT, now which is also the average energy associated with thermal fluctuations. Now this means that these structures can actually be broken down by thermal fluctuations. And now there are four main categories of soft materials. They are amphiphiles, colloids, liquid crystals, and polymers. And all of them, they are grouped under soft matter since they have some common characteristics. So let's have a look at these common characteristics. Right. So first of all, they show a very large and non-linear response to external forces. Now, this large response is a consequence of the fact that these mesostructures are actually very weak in nature and they require a very small amount of energy to break them. Now, what is meant by a non-linear response is that unlike elastic materials or liquids, soft materials don't have a linear relationship between the stress and strain. Furthermore, they show a slow response to external forces because of the large size of their molecules and also the inertia, so the inertia associated with them. And hence they're usually found in the non-equilibrium state. For example, ice cream. We know that ice cream is actually found in the non-equilibrium state because there are actually air molecules trapped inside the ice cream. In the equilibrium state, after a sufficient amount of time had passed, they would have been ejected. Now, also soft materials, since they are found in the non-equilibrium state, the properties are path dependent. Again, if you take the case of ice cream, we see that the ice cream which has been made, say in a factory, it tastes very different from ice cream which has been made like in our freezer. Again, this shows that soft materials, their properties are actually dependent on the path or the process by which they are made. So now let's discuss two of the four main categories of soft matter in a little bit more detail and see what makes them so relevant in today's world. So first of all, let's have a look at amphiphiles. Now these are molecules which possess a hydrophilic or water-loving head and a hydrophobic or water-hating tail. An interesting property that they have is that they're actually soluble in both water and oil because of micelle formation. And because of this property, they have lots of conventional uses, like they're used in detergents and soaps, emulsifiers, dispersants, foaming agents, etc. They even use as stabilizing agents in food additives, creams, cosmetics, basically materials which contain both hydrophilic and hydrophobic components. Basically, what these surfactants or amphiphiles do is they cause both these components to mix thoroughly, thus prolonging their expiry date. Now recently, nanoparticle amphiphiles have been developed, which have lots of exciting uses like controlled drug delivery, nanoreactors, artificial enzymes, biosensors, etc. We also have liquid crystals, which like all forms of soft matter are between crystalline solids and liquids. Basically, crystalline solids contain complete order, liquids don't contain any order, and liquid crystals, they contain partial order, and this gives them interesting anisotropic properties. Some important applications are bulletproof vests, LCD screens, which we see in our smartphones, TVs, etc. So again, there are many more types of soft matter with a vast variety of uses in the chemical, biomedical, materials industry. And again, these are highly relevant in today's society. Okay. Finally, I'd like to thank Professor Shalini Gupta for giving me the opportunity to do this presentation on such a relevant and exciting topic, and also my parents for their everlasting support. Thanks.